Hi everyone. Uh, Thank you for attending the talk. Today I'm going to talk a little bit different from some of the things we have been hearing today. It's going to be less of what our AI agents can do and more of what I'm scared of the agents, what it can do, and how I deal with my insecurity of the agents. So, hi, that's me. That's prior to the agents became sentient. It did not talk to me at that time, my friend. Hi, I'm Rabimba. I am a Google developer expert. I'm also a scientist at PayPal, but today I'm going to represent more of Google things. So, yeah, let's start get into it. How many of you are building something that has an LLM component in it? Awesome. Actually, when I ask this question, a lot of people, more people raise their hand, and which makes me even more scared. So, like any systems, AI applications has vulnerabilities. We all know that. But did we actually comprehend what are the problems we can have? So this is kind of like a whole life cycle of the things I have faced throughout working in couple of end-to-end scenarios using LLMs. So we're going to talk some of these and we're going to categorize them in certain specific parts and then map them how our AI agents, which is a troublesome term because I still don't have a very good definition of what an agent is. But we are going to look at some of the things we think are agents and how they can be affected by them. So first, so this is a secure framework Google came out with, SAFE. It's called Secure AI Framework. And when it came out, a lot of us thought, oh, this is awesome. We just follow this and everything is going to be awesome. It did not happen that way. So what's happening and what a lot of us are seeing is that AI became a very fast-paced, dreamy scenario. Every day you have a new model coming up. Every day you have new frameworks coming up, new AI agents, OpenClaw. Before you can even download OpenClaw, you realize it was called something else. Then it became something else. By the time Cloudflare came with a Molt runner, it was not even Molt anymore. So it's very fast-paced, and the solution explored in this talk appropriately. So what's happening and what a lot of us are seeing is that AI became a very fast-paced, dreamy scenario. Every day you have a new model coming up. Every day you have new frameworks coming up, new AI agents, OpenClaw. Before you can even download OpenClaw, you realize it was called something else. Then it became something else. By the time Cloudflare came with a Molt runner, it was not even Molt anymore. So it's very fast-paced, and the solution explored in this talk appropriately agnostic to this fast-paced new models. So let's look at our whole AI system tool map. So you have your models, and then of course those models has to be run somewhere. So you have your infrastructure team, you have your data where the model is that's model's playground, and your application which your user is supposed to be exposed of. And then on top you have the governance and assurance, which a lot of time comes as an afterthought, even though that's on the top, and that brings us a lot of grief and problem down the line. So let's decompose this a little bit more. So when we look at application component, you probably have some of these. So you have an application, you have a model plugin. In your model component, you actually have your model, be it open-weight or in-house model, or you are using somebody's API. And you, of course, have a way of interacting with it, which is the input and output handling. You are going to serve that model from somewhere in some capacity. That's going to be where your model is getting served if you are doing in-house AI. And if you have a team which proposed to you maybe 6 or 7 months back that, okay, we can do this. We have this kind of data. We will come up with our own model. We will fine tune this and this. And they did a very shiny demo. You were convinced. You gave them go ahead. And after that, Once that goes to production level, you now have a lot of problems. So you also have this infrastructure component where you are dealing with data storage. This is how the planes look like. So you have the control plane, you have the AI risk and risk. Why they are different, we're going to go to that. So we are going to talk each of these parts very briefly. I'm going to not go too much into the application part today. So first, data. If you have your AI models being fine-tuned, or maybe you are big enough that you are retraining on it, you will have a way of handling that data some way. Why does it matter? Where is your data coming from? If I may ask, any of you have maybe just for fun fine-tuned a model or just ran a collab and did a fine-tuning? Awesome. Most of the time, we just use some of the example data set or do something on top of that. And if you have a big team, they probably are using your either in-house data or some of these data from internet maybe to fine-tune the model or do something like that. We do not think about data poisoning or model poisoning. Why that matters? There are two parts of it. A lot of times, imagine you are building a specific AI model, which is supposed to look at all of your log files and supposed to say if there is something weird going on in that log or not. How do you fine tune it? You might have your own huge log data set, or you might be tempted to use something which somebody did in Hugging Face, use that, do something on top of it. How are you sure that that specific model has not been fine tuned on a data which has not been poisoned before? How do you know about data provenance? And how do you know the model itself is not poisoned? So many products use kind of like user reporting flow that can be abused. So for example, Gmail manual reporting false flags. So if you have a team of Claude bots and you create like 100 of not Gmails, some kind of email, let's call it Gmail, and you have a very specific way to send a lot of specific emails and have another Claude bot constantly marking them as false, marking them as spam, you can train the classifier to learn a very specific pattern it should not learn. That was a nice example, which probably not going to happen. But in your in-house modeling, you should have a data sanitization part very specifically for the training data. Why? So when you do any kind of data validation and anomaly detection, this will matter of or like how you have trained. So when you have this whole cycle, you have a user data management, you have a training data management, and you have a data sanitization part. Now, also, how do you prevent unauthorized access using strict access control? This has been very normal architecture for a long time, but uh, but in scenarios where you have fine-tuned a very specific model, it's open to your developers and they can access it to maybe get a documentation out. How do you ensure that model is not going to answer an intern about something which they're not supposed to know? So this access control we are talk about in more detail, not only on the training side, but also on things like retrieval augmented generation. How do you ensure some of the things which are coming from your data set is not exposed to agents or humans who should not have access to that? That brings us to infrastructure, because you need to have certain things to ensure your training and fine tuning and serving is done properly. So this is how it looks like for most of the in-house organizations, at least the smaller ones like mine. So you have model and data storage, you have a serving, you have a training evaluation, and you have frameworks. And one thing I'm missing here is benchmark. Now, let's start with model source tampering. This is already old. So Hugging Face ran a study to see that how many of the models it was hosting has intentionally been tampered. And you will see they found quite a lot. So one of the examples like this you can recreate is model poisoning through Python's pickle. So pickle is a Python's default serialization model. It converts the objects to byte stream and vice versa. How it can be exploited? It can be exploited through the reduce method. How? Let's see. We're not going to look into this slide more because we're actually going to see a demo if it runs. So here we have two VMs running side by side, and on one we just look into the code, and on the other side that VM, whenever somebody, so how the thread model works is that the thread model is you have already poisoned the pickn file, you have uploaded it to Hugging Face or distributed through some other channel, and the user has no idea it has been poisoned. So what they're going to do, they're just going to run the uh, uh, like they're just going to load the model, and they're going to interact with the chatbot how they are supposed to, and on the back end we should be able to get access to their machine. Did I go to the second? Oh, yeah. Okay. So this is actually available in GitHub and Hugging Face, so you can actually play with this. Do not run it on your own computer. Because this will open up a port, and it has placed this I tried. This was 6-7 months back. Windows does not mark this as a malicious file. So let's go forward and look how it actually should look once you access it. So this is the ONNX loader. So we can distribute it. It's 30 MB of your whole model loaded, and when they run it, oh, this we already saw. I do not like PowerPoint. So funny thing, which I was just explaining today morning, I realized suddenly this is my office laptop, and uh, some policy change happened. I cannot access my personal Google Slides anymore, so I had to download and depend on it. Excel, sorry, PowerPoint. So go forward. Where is? Wait a minute. I want to show. Okay, so this is the slide I wanted to show you. So this is like they're accessing the application, fairly simple grad.io application. On the right, if you see that it immediately opened up a reverse shell, and the attacker can see whatever files is available in your file system. So this is very straightforward attack through Python pickle. This has been documented well enough. If you want to try it, you can scan it. You will be able to use it in your own machine on VM. So going back to our talk. So architectural backdoors in neural networks are a thing. So you can have a system where if you have a model, you can train the model very specifically to learn certain patterns. It will work perfectly fine for every other responses. But if you have very certain keywords in the responses, it will go in a very different path. Why this is important? We have seen models being used directly from Hugging Face to do certain classification tasks, to do certain other tasks, where those models are being loaded by an agent, and that agent was not aware of course, the developer was also not aware of how it should work for a very specific scenario. And that loaded a very specific command, which told the agent to forget some of its guardrails and do certain stuff. And since these are multi-agentic system, everything after that fell in a chaos. So backdoor model code to get remote access is what we just saw. Now, this generally happens when you only have unauthorized training data, which you can still mitigate to some extent if you can completely control your whole end-to-end data provenance, which becomes a problem if you are only a shop which is fine tuning on existing models. So AI specific risk. There are already models like this which are available, which is fine tuned on backdoors, which are fine tuned on CVEs and other problematic codes. This opens up a huge threat model for us, but this also is very interesting. You can use some of these to do internal red teaming, to have an agent which constantly tries to break your system for very specific task. Now, that idea, even though is enticing, you still need a complete end-to-end secure ML tooling for your team to work and build these systems, which again brings us to model and data storage, serving, and the whole control. How do we do that? So implement a verifiable provenance using cryptography, implement very specific systems, access controls inside your agent. How does your agent gets the scoping? Does it get the scoping from the user who is running it, or is it the system level scope? What exactly it's supposed to work on? If it what kind of data is it's supposed to get? Is it expecting a JSON data and got something inside that data which doesn't look like JSON? All these should be part of your system. So we talked about model exploitation, and that brings us to like model data storage. Now, then there are other attacks like bearer token exposure and loss. If your model has been trained on a lot of your internal data set, maybe code, have you ensured those codes does not contain specific patterns of specific things which your model should not expose? If it has not been, if you don't have ability to do that kind of data sanitization, does your model have a very specific guardrail and classifier, not only in the model stage, on the agentic side as well, to prevent that? Remote model with reconstruction is also a thing where people try to reconstruct the weights of your proprietary model. And one of the easy ways to, not exactly reconstruction, one of the easy ways is, of course, distillation of your model's capability, which took a recent stage through one of the tweets Anthropic did. Now, throughout all of this, one of the huge things which is coming up for us is data access control. I'm going to go a little bit faster here. So how do we ensure our models and agents which are accessing those models require authentication? The talk just previous to my talk was excellent on giving you a lot of ideas about that. How we are doing it is very specifically is scoping each of the agents. Each of the agent for us, agents are nothing but very specific codes which are given certain responsibilities to do certain stuff using some LLM that can be very specific models for that agent or something generic. But we ensure very specifically they all are siloed and their authentications are separate from the other agent it's going to call. So this is how, if you look at the whole scenario, these are all of the things we have to take care of: the exfiltration, deployment tampering, poisoning, source tampering, training data tampering. And if you look at how we kind of deal with this is, of course, red teaming on the left side, data and access control, secure ML tooling is your infrastructure part, adversarial testing, and all those. So this brings us back to models or agents. So how do you safely process a user's input and a model output? So model input handling, output handling, this is what it leads back to. So what is unsafe model output? For us, this is mostly a very specific pattern, specific information which should not come to the user. That can be private information, that can be sensitive information, that can also be harmful or very stylistic kind of harmful information. So unsanitized output does lead to arbitrary code execution. This is very prevalent specifically on agentic side, where we have multi-agent and some of the agents are dealing with code executions. And then you also have our adversarial training, which works on that. How much time do I have? Okay, so since I have 5 more minutes. So some of the things we are doing is that organizing red team exercises to model safety and scrutiny. And this is not as easy as it sounds. Prompt injection is a very small part of the equation, which is for most of our systems is mostly solvable by having multiple layers. What's more problematic is creative parts. For example, having invisible image content to hijack result accuracy, for having logs which have been tampered with, which when passes through your log processing system specifically suppresses some result. So input validation sanitization is still a huge thing, and we are starting to have agents, or I would say classification systems, which looks into the input even before it goes to any kind of LLM. So what we realized is that you should have a lot of dedicated input and output security classifier, code sanitizer, and just sandboxing them in our experiments were not enough a lot of times. So sensitive data disclosure, that is one of the huge things if you are working for a healthcare or a financial company. And that brings us to some of the privacy enhancing technologies which we are doing is specifically on the training and tuning part. Your evaluation should capture not model's accuracy, but very specifically what you want the model to output, or also what you want your model not to output. That has been a huge push on our side, that you should have very specific evaluation which captures the things we should not let the model to happen. Some of the things, this is more into the model training side, differential privacy training so that model does not learn and recall private information. This has been a very huge push, very specifically because a lot of data we deal with becomes a little bit less useful if you take everything out from the training data just before training the model. But if you train the model, we cannot guarantee ever that it will not be exposed. We can empirically show, but we cannot guarantee that. So differential privacy has been one of our tools to employ to give certain guarantees that yes, this is not going to come out. So we started with all this stack of like prompt injection, sensitive data disclosure, inferred sensitive data. This is very interesting. This inferred sensitive data is not essentially a data which is part of your model should be outputting. For example, we have seen attacks where your model is supposed to only produce code, and it does produce code. And then somebody asked it to produce very specific code that produces a very specific kind of text and image, which the model should not have known about that. But since we don't control the input model, we don't control the pre-trained model, so only fine tuning was done on those models. It came out with certain information which was not part of its original design, it was not part of its original output. And remember, this model just outputs code, so it should not be able to output any kind of text. Like nobody cared about private information getting output from that model, but people were still able to ask it to write certain type of code, which when you chain, that code was able to give information which the model was not supposed to output. So input validation, adversarial training, output validation, all of these are part of the toolkit, which enables us to safeguard it to some extent. None of that, we deployed all of them, but none of that still stopped that agent to provide certain kind of code output which disclosed our sensitive data. Hence, at the end of the talk, I will always say this is a running goalpost for us. So the takeaway from the talk or takeaway from my experience here is that how we can look at the kind of like the AI risk or the agentic risk and specifically in this multi-agent architecture is a combination of classical issues, classical ways we were dealing with it even before AI came into the place, but also having very specific safeguards so that your output, your input, they're all sanitized, and also your training whole life cycle is sanitized. So if you want to apply some of the things we talked about here, so review your AI workflow, review your workflow from end to end, from your modeling team, the science team, to the implementation team, to the team who is providing the data. And in the next 6 months, maybe improve your security of auditing controls even more, because a lot of the stuff we realized our agents we could not have was doing, we could not have done that without very specific auditing trails. And we have realized the more you have multi-agent system, the more complex the data flow, more complex it becomes the audit trail. So top 5 practical recommendations if you want to kind of like do that in your system. If you scan that code, it has a very small, lightweight, complete end-to-end implementation of certain things I talked about here. So how you can have a very specific access control in model, how you can sandbox, how you can filter, sanitize all those outputs. With that, I am almost at the end of my talk. Thank you. If you have any questions, I'll be happy to take it. And if you scan this, it will allow you to give feedback on the talk. Thank you.